Hello, it's Dumplet here. Welcome to a tutorial on exponential inequalities. Now, if you haven't watched the last tutorial on exponential equations, I highly recommend you to go back to that video before moving on to this one. Alright, so just like the last video, I'm going to tell you what exponential inequalities are. It's literally changing the equal sign into an inequality sign. So we have some examples here of the inequality signs. The greater than, the less than, the greater than or equal to, and the less than or equal to. So if the left side and the right side involving like exponential terms, and then they're related by an inequality sign, then obviously they're called exponential inequalities. All right, but the way to go is very much similar to exponential equations. We're going to do the same thing, making the left and the right side have the same base. Now I wrote here a question mark because it's not an equal sign anymore. It can be any of the four inequality symbols, so just a question mark. And we would be able to start here, the b raised to x, and the inequality symbol b raised to y, and then moving on to this part, where x, some inequality symbol, and then y. Because there are some rules that you have to apply that is kind of new, but generally speaking, that's going to still be the way we're going to solve these inequalities. All right, so let's dive into the first example. All right, so the first example, it's 4 raised to x is greater than or equal to 64. Now, if this inequality symbol was an equality symbol, then this is going to be the way. I just copied that from the previous video. So x here would be equal to -3, but everything is pretty much the same. What we have to do is make sure that the left side and the right side have the same base, and then just copy the inequality sign for now. So for example, if I have 4 raised to x is greater than or equal to 64, I'm still going to do the left side and the right side, make them equal to the same base. Let's just make it 4 raised to x, 4 raised to x greater than or equal to, and then just copying the sign, and then the right side becomes 4 raised to -3. All right, now here is the additional rule that we have to do, because what we did back in the equations was we just simply equated the exponents. But in inequality, we cannot directly write the exponents down because there's an inequality symbol, and there is a rule for it. If the base is greater than 1, then we retain the symbol. So if it's greater than 1, we retain. If the base is less than 1, we're going to do the switch. Now, if you forget if we're going to retain or switch, we can try to do some simple exercises. For example, the base now is 4. Now you might want to try to check if 4 raised to 3, 4 raised to 3, that's obviously greater than 4 squared. Now how would you relate the exponents? Well, 3 and 2. Now 3 is obviously greater than or equal to 2, so we're going to retain the symbol. Again, if the base is greater than 1, we're going to retain. If the base is less than 1, we're going to switch. And that's going to be the only additional thing that we'll be including in inequalities. That's going to be a common theme that you're going to see later. Anyways, now since the base in this expression, in this inequality, it's a 4, so it's greater than 1, so we're going to retain the inequality symbol. We're going to do the retain. So we're going to retain the inequality symbol and then relate the exponent. So x and -3, we're going to retain the inequality symbol, and we're going to get that x should be greater than or equal to -3. Now obviously this is just in this format, but you can write it in another form. The set builder notation, interval notation is totally up to you. But generally speaking, that's how we solve an exponential inequality. Now let's go to the next example. We have 2/3 raised to x greater than or equal to, greater than 16/81. Again, if this was an equality, if this was an equation, then we're just going to write the left side and the right side with the same base and then equate the exponent. Now we're generally going to do the same thing. We're still going to write the left side and the right side with the same base. So 2/3 raised to x. Just copy the sign for now. And then we have 2/3 raised to the 4th power. Again, that's going to be our first agenda in both equalities and, for equations and inequalities. Now here's the part where we have to make a decision. Again, if base is greater than 1, we retain the sign. If base is less than 1, we switch the sign. Now, what's the base in this example? It's 2/3. Now, 2/3, that's obviously less than 1. So we're going to do the switch. So we're going to do the switch here. So it's a greater than symbol. I'm going to switch it to the other way, so less than. Obviously, if it's a while ago, if it's a greater than or equal to, so if you're going to switch it, it's going to be less than or equal to, so just know like the pairings. So obviously the greater than and the less than go together, and the greater than or equal to and the less than or equal to, they go together. So that's what we mean by switch. We literally switch to the other side. So here it's a greater than symbol, now we make it into a less than symbol. And then that's going to be the sign where we relate our exponents, the x and the 4. So to answer this question, x here should be less than 4. Again, everything is practically the same as exponential equations. All we did is just additionally checking the base to know if we're going to retain or to switch the sign. All right, let's do another example. So 1/3 raised to x is equal to 9. Is less than or equal to 9 raised to 2x minus 1. Again, it's generally the same thing. So in equations, though, we're going to do something like this. Again, writing it as the same base. But the problem is, if I'm going to do it in equations, it's just literally going to be negative x equals 4x minus 2. And then we have to do an additional step of solving for x. Now, it's practically the same in the inequalities because, well, as I said a while ago, what we have to do is make sure that the left and the right side are written in the same format. So in this case, let's just make it the base of 3. Again, you can write it in a lot of other bases probably, but for the sake of demonstration, I'm just going to use the base of 3. Again, just copy the inequality symbol for now. And then this part, apparently, as we got in the previous video, it's equal to 3 raised to 4x minus 2. Now we're going to do the decision again. Now the base is 3, so the base is greater than 1, right? Base is greater than 1. We're going to retain the symbol. So it's going to be less than or equal to. Now we're going to relate the exponents. Now the exponents are not, like we won't immediately get an answer as we did in the first two examples, but it's going to be the same thing. We're going to relate negative x and 4x minus 2 with this less than or equal to sign. Now what's the last step? Same thing, solving for x. So it's just a solving for x in an inequality now. So negative x is less than or equal to 4x minus 2. Let's just say we're going to put the x on the other side, and then let's put this 2, a negative 2, to the left side. I'll be getting 2 less than or equal to 4x plus x. Now that's going to give me a total of 5x. Now 2 is less than or equal to 5x. I'm pretty sure from here I would be able to get that. We can kind of switch this so we can kind of read this from left to right. So we have 5x greater than or equal to 2. And then last step is just divide both sides by 5. So x here would be greater than or equal to 2/5. And that's going to be the way to go. So that's it for this one. Now let's go to the last two examples. Now obviously you don't have to write the equality version down. I just showed you guys that for reference. Now when solving, you can just kind of treat the symbol that you're dealing with an equality for now, and then just do the switch later. You don't have to write this left part down with an equality. You can just work it as normal. So for example, I'm just going to make sure the left and the right side are with the same base, so 25 raised to x, and the 5 raised to 3x minus 1. Let's make it a base of 5. So 5 squared raised to x, and then 5 raised to 3x minus 1 on the right side. So again, the goal is just make sure that you're able to write it in the form with the same base. So 5 raised to 2x, and then the right side becomes 5 raised to 3x minus 1. Now let me write it both in red, just so you guys can see better. And again, just treat the symbol, just copy the symbol for now. And then after you make them the same base, you're going to do either the switch or the retain. You're going to make a decision here. Now the base here is 5. So, all right, base is greater than 1. We retain the symbol. So take this and then write it again. And then use this to help you to relate the two exponents. So 2x and then the 3x minus 1. Now let's put the 1 to the other side, and then 2 to the 2x to the other side as shown here. And we're going to get the following. We're going to get like 1. It's less than or equal to x. So because 3x minus 2x is x. So 1 is less than or equal to x. So what we're going to have here is just, well, we can write it in a better format. So we're going to get x should be greater than or equal to 1, just to switch the sign. So we can kind of read it better from left to right. All right, but anyways, that's going to be the answer to this one. And then similarly, let's try to do the 4 raised to x squared minus 2x is less than 64. Again, you don't have to write an equation down. Just treat the symbol as if it was an equation. Treat this symbol as if it was an equal sign, and just work as normal, because the goal is just to make sure that the base of the two sides are the same. And then we're going to do the relationship to switch or to retain the symbol. Now the base here is 4, so we're going to retain the symbol. So x squared minus 2x, and then the 3, we're going to retain it with this less than symbol because the base is greater than 1. And the last step is to solve for x. Again, it is quadratic now. So last time we did something like factoring and solving for x. Now here it is a quadratic inequality. It's a bit challenging, so you guys have to kind of recall your lessons in quadratic inequalities, but I'm going to quickly show you guys here. X squared minus 2x minus 3, that's going to be less than 0. And then we can still do the factoring, x minus 3, and then x plus 1. Now, all right, now, yep, if I'm going to write this down, if it was an equation, then x would be equal to 3 and x would be equal to negative 1. But in this case, what we're going to do is write down the values that makes these two factors 0. And then remember how we have to test values in each region. For example, I'm going to test negative 2 in the left part, and then I'm going to test a 0 in the middle part, and then I'm going to test like a value of 4 in the right part. And then these test values will tell us which values of x we're going to be using. So you can try to substitute negative 2. You're going to realize it doesn't work, so this region doesn't work. If you're going to substitute 0, you're going to realize it is going to work, because negative 3 is if you substitute 0, this left side becomes negative 3, and it's indeed less than 0. So a check mark in the middle, and then you can check the x equals 4 case. It's not going to work. So to answer this question, we know that all values between negative 1 and 3 would work. That's how quadratic inequalities work. So a test value of 0 telling us that values between negative 1 and 3 will work. So I'm going to write this in terms of an inequality. So as I've mentioned, all values between negative 1 and 3, they're going to work. So I can write x as, I can write x as follows. So x is between negative 1 and 3 with the strict inequality. So because, as you can see, actually, the signs are kind of consistent because we're just switching or retaining the sign. So for example, we started with a less than symbol. We're going to end up with a solution that involves either the less than or the greater than symbol, because we either retain or we switch. Now, if it was a less than or equal to symbol, take note that the answer to the question, it's going to be something with an equal to as well. So it's either less than or equal to, or the greater than or equal to. So maybe there will be an equal to. So as you can see here, these two parts, the equal to, they're consistent. And here there isn't an equal to part, and it's consistent with the answer. So that's going to be a general theme, as you can see here. So those are the small things that you might be able to observe. Anyways, so that's all about exponential inequalities, and hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!